so welcome. I know more and more people are starting to come in. We will begin very shortly. Feel free to use the chat to introduce yourselves if you're in the audience. We'll get started very, very soon. Just to let you all know that this session is being recorded, as are most of the other sessions that we have. And so if you have any audio-visual problems while we're live, then you'll be able to, they should be available next week on the UCGIS webpage. So don't panic if you lose us for any reason. Okay. I'm going to leave it maybe another couple of minutes just to make sure that we can get more people coming in. We have, well, we're stable at 34. Okay, now I have to figure out all my timing again. All right, so should we get going?
Yes, we should. Yep.
Okay. All right, let's get going. All right, so this is our official welcome to our session on recent developments, policy implications, and the future of unmanned aerial systems in the geospatial field. So good afternoon, everybody. Welcome. If you've been sitting through all of the sessions, you're probably getting a little stir-crazy. But this session has been organized by myself and Paddington Hodsa from University of Wyoming. This session, it's a kind of a panel discussion session. So we're going to be hearing from our three experts we tried to get people from the private industry sector, government, and academia to talk to us about how their organizations use or in some way interact with UASs. Including things like the policy implications of UASs from their perspectives, and providing thoughts on some of the risks, the challenges, and possibilities of UASs. Once we've heard from each of our three speakers, we're then going to move into a discussion and Q&A type session. That's going to be led by Professor Stephanie Rogers from Auburn University and Adam Matthews from Western Michigan University. And they're going to drive a conversation that will really focus on issues of interest to academics in the geospatial field. So I'm pretty excited to see how this is going to go. As I've said, we'd like this to be as interactive as possible this session. Obviously, with this venue, it's a little bit difficult. But please put your questions, audience members, in the chat. You can just keep adding questions to the chat throughout the talks. Paddington and I will field the questions. We will make sure that Stephanie and Adam have those questions to respond to during the discussion and the question Q&A. So they'll be leading that conversation for us and, asking our panelists or our experts to respond to those. Okay, so without more ado, why don't we get started? So first up, so what I'll do is I'll ask the people who are not speaking to leave, and then they can come back in when you're about to speak. So our first speaker is Tombo Jones. He's the director at Virginia Tech Mid-Atlantic Aviation Partnership. I'm not going to further introduce him because I know that he's going to tell us everything we need to know about his organization.
Thanks, Jane. And I want to say also thanks to Paddington, both of you, for hosting this discussion today, and also want to say that I'm honored to share the stage with Dean, Lance, Stephanie, and Adam. So thank you for having me today. I am the director of the Mid-Atlantic Aviation Partnership, and I work at Virginia Tech. So we are one of the FAA designated test sites. there are, across the nation, there are seven test sites, and we were established back in 2013, and our responsibility there as a test site for the FAA is to help integrate drones into the national airspace and to figure out how to do that safely. We're also part of the Beyond program, and the Beyond program was just started this past year as a follow-on initiative to what was called the Integration Pilot Program. And both of those are more recent initiatives at trying to figure out how to safely integrate drones in the national airspace, and also more specifically to look at the challenge of beyond visual line of sight operations. About 50% of our research is done for government-related entities, and 50% is commercial. And the Beyond program is very much a government and private partnership to try to figure out a pathway forward. So I'm going to talk a little bit about that program. So under the Beyond program, we here at Virginia Tech, and it was also under the Integration Pilot Program, we had three focus areas. One is package delivery. The second is linear infrastructure inspection, and the last is post-event damage assessment. Under the package delivery program, we work closely with Wing, which is a Alphabet company, so a sister company to Google. And then linear infrastructure inspections with Dominion Energy, and then State Farm is our partner under post-event damage assessment. Now, under the Integration Pilot Program, we had some great success figuring out, under Wing's leadership, we supported them through research. They were able to achieve the first Part 135 certification. So it's for a drone. So it's the first time a drone had been put through that process. And we're pretty proud of that, because as we move forward and try to figure out ways to gain approvals for drones, many of them are going to be forced through traditional aviation regulations, and that's just a prime example of that partnership with the FAA and Wing, where we were able to achieve that. I will speak more specifically to the post-event damage assessment. You may recognize the drone that's being operated there. We chose that drone not because of its incredible mapping capability. That is something that it has, but we chose it because it's very lightweight and small. And what we were able to do with that under the Integration Pilot Program is to get through quite a bit of research in assessing the ability of the drone, as well as its reliability, and if it were to strike someone, just how the lack of severity that it would have. We were able to get a waiver to operate over people and beyond line of sight in Class G airspace. So the thing about the Beyond program is that it really focuses on beyond visual line of sight. And I want to just dive in a little bit deeper here on the importance of beyond visual line of sight operations. So many of you, if you're already operating drones and doing mapping and survey missions, you likely realize that having to do these operations line of sight, which is currently where the majority of operations sit in the U.S. airspace, it's very limiting in your ability to efficiently conduct operations. So under the Beyond program, we're really looking hard at how to accomplish getting beyond visual line of sight. So we have our three-legged stool, and so our research is focused on those three areas: operations over people, command and control, and detect and avoid. And these are the three research areas that really need answers in order to crack open what is largely 99% of the operations that would be able to occur. So we'll talk first about operations over people. So fortunately, the FAA this year came out with a rule that is helping to start to answer the mail on this. So under current 107 regulations, I think most folks might know, or you may not know, but you're not allowed to fly over people or over moving vehicles. And so that becomes real stifling when you're trying to map a particular area, especially if it involves, roadways, for example, or places where people may sometimes, be under your flight path. And so the new rule is very specific in the types of categories that you need to show compliance with in order to fly over people. And it also includes the FAA's most recent technical ability to TC an aircraft, technical certification to get approval for aircraft that are sometimes larger or heavier. So we're looking hard at each of those. There's different ways to do that. I do have a picture of a parachute here. There's an ASTM certification that's out for parachute, and we've done some research in that area too, and are looking at how that might be applied against the rule to gain approval to operate over people. So that's pretty important. The next part of the three-legged stool that we've been looking hard at is command and control. So when we operate our drones line of sight, it really hasn't been a problem. Most of the commercial off-the-shelf drones that you buy today are going to be Part 15 compliant, which means it's not operating on licensed spectrum, and which means that it is subject to some interference. And so the writing has been on the wall with much of the research we've done to try to get towards beyond visual line of sight, that in order to get approval to operate beyond visual line of sight, there's going to have to be a move to licensed spectrum, so that when you're further away from your transmitting source, you're not receiving interference that could cause the drone to have a problem, and to we don't want to decrease reliability. So most recently, this past August, there was a report done by the FAA in conjunction with the FCC on Section 374 that focused on both L-band and C-band. And so we've been researching that quite a bit. We've done some C-band research, but the bottom line here is that as we move forward, we have to find ways to be able to communicate on licensed spectrum. Now, fortunately, LTE is considered to fall into that category, and so you're going to see probably the most common communications outside of the Part 15 compliant non-licensed is going to be LTE. So that we feel like this is probably going to be, out of the three-legged stool, the least challenging, but it is a portion that has to be answered. And then the most challenging portion of the three-legged stool is detect and avoid. So 14 CFR 91-113 is the regulation that states that traditional aircraft pilots, if a pilot's sitting in an aircraft, that they're responsible for seeing and avoiding other aircraft. Well, drones under 14 CFR 107-37 have the exact same requirement. And without an operator sitting in the seat, we have to rely upon technology to deliver the mail for us on being able to detect and avoid other aircraft. And it seems like that would be a simple solution, just because of some of the technology that's out there, such as the radars that provide guidance to aircraft that are flying, traditional aircraft that are flying on instrument flight plans and that type thing, or even transponders of type. But we have a number of aircraft that are allowed to fly without transponders. And so the charge right now is to focus really hard on trying to find detect and avoid solutions that can identify non-cooperative, as we call it, folks without transponders that are flying around. So we're working really hard to try to look at that. It's very nascent. We're early. We're kind of in the crawl phase of trying to answer the mail on this. And we've done a lot of research with a lot of different types of sensors. You can see pictures of some of those different sensors that we've done research on. Some are radars, some are EOIR cameras, even acoustic detection systems. And some of the pictures on the right are some of our simulations that we've built to try to provide a statistically significant sample so that we can speak to the efficiency of these type systems. So as we move forward, the future is really where it's at. In order for us to do efficient mapping missions and really look at areas, we need to have the ability to conduct that, sometimes crossing roads, sometimes flying over people. And so we're working hard here at Virginia Tech to answer the mail on that research. And that's my last slide. So Jane, I'll stop sharing.
Great. Oh, hold on. I did something wrong. Hold on. Okay, I pressed the wrong button. I apologize, everybody. Sorry. Great. Thank you so much, Tombo. That's great. We'll hold questions until after once everybody has spoken. So thank you very much. And actually, I forgot to mention to everybody, if you go to the polls section, right next door to the chat, to the right of the chat, there are actually a few questions in there, just a couple of questions that we'd like you to respond to as an audience member. So if you can just, while people are talking or while I'm nattering on right now, if you wouldn't mind answering those questions, that would be really great. Thank you. All right. So now we're going to be hearing from Dean Griffith. He's from Jones Day. And again, I know that you have your slides. Are they going to work for you?
Yes. Let's find out.
Excellent.
Great.
Got it.
Okay. So after a year and a half of remote work and the like, learning a new system is always a little bit easier now, but there's always a challenge. Anyway, so thank you very much. Thank you to UCGIS for the invitation to participate today. My name is Dean Griffith. I'm of counsel at Jones Day in Washington, D.C., where my practice focuses on FAA regulatory compliance and the like. When I was at the FAA, prior to coming to Jones Day, I worked on the drone program quite a bit, including in the early days of the regulations and the like. So I'm going to add my perspective here on current ways that you can operate drones under the law, and then also some best practices that organizations should consider when operating drones for research and other uses. And so, big picture, we're in an environment where using drones is getting easier. There's more ways to comply. We're moving from an environment where all operations have to be individually approved, moving now towards increasingly operations that are just in regulation that you can comply with, that you don't have to seek that individual approval, but it's in flux, it's in development, where we still have a long way to go in that regard. And while the FAA is making progress, certainly, as with a lot of technology, it's outpacing regulations. The FAA just can't keep up, and frankly, it's not, the regulatory process is not a fast-moving process by design, right? It's a deliberative process that seeks public input. The agency spends tremendous amount of time and effort developing proposals for public consumption. So that's by definition a slow process. The FAA is working towards performance-based regulations rather than prescribing exactly how to comply. They provide standard performance-based goals to meet, and the manufacturer, the industry can decide what's the best way to achieve that and propose ideas to the FAA. And really, kind of in the early days, you think about a drone has more in common with consumer products than aircraft, even though they're aircraft, right? It's more like a cell phone or a computer. In fact, you could argue it's a flying cell phone or a flying computer, right? So the technology changes so quickly, and coming from the technology background, the Silicon Valley background, it was hard for the industry to initially adapt to that FAA mindset, right? And so, and the FAA, frankly, was also not sure how to adapt to the Silicon Valley mindset. But I think there's been a meeting of the minds, if you will. They've come to kind of a working understanding, and so I think that's really helping progress. And then in addition to complying with the rules and the laws, organizations need to adopt best practices internally for a couple of reasons. One is for liability. You want to make sure you know who's operating your drones and the rules they need to comply with internally. And it also helps you eventually make if you need to make a safety case to the FAA, you can use that information to do that. So what's driving federal drone policy right now? Really three things. Drone user interest, right? Industry wants to move forward. Industry wants to remove barriers to new uses and expand their existing uses. It's really a situation where kind of it's usually the opposite of what you think industry wants, which is less regulation. Here they want more regulation, but regulation to allow different kinds of drone uses. As Tombo talked about, and I'm going to talk about a little bit later too, Part 107, the base rule for small UAS is fairly restricted, but to be able to open that up by rule is something that the industry would be interested in. Hobbyists, model aircraft, the model aircraft hobby is old. It's been around as long as aviation has been, and they had a pretty significant hand to play in early drone policy in particular. Law enforcement, they're concerned about proliferation of drones. How can I, one person's flying a quadcopter, another person's flying the exact same quadcopter. How can I tell if the first person is using it for good, good or nefarious reasons, and the same with the other, right? It's hard to tell just on its face, especially because they're relatively anonymous. They're separated from the operator. They're small. They don't have to go land at an airport like any other airplane usually does. So there's some unique challenges there. They fly at lower altitudes, that sort of thing. And that also features into some of the privacy concerns that people have around drones. The state and local governments have been very active in this area, particularly early on. There was a perception, I think, grounded in reality that the FAA wasn't acting quickly enough, and state and local legislators were hearing from their constituents. I'm concerned too about privacy and issues like that. So they were very active early on, and they still continue to be active. So people need to be aware of those laws too. So this is, don't worry, this is just one slide, the basics of aviation law, that kind of will ground us in the further discussion as we go along. Drones are aircraft, right? Congress in 2012 said drones are aircraft, FAA therefore has jurisdiction. That's why we're so interested in what the FAA has to say and why the FAA is spending so much time in this area. And then Tombo had a three-legged stool, and I have a three-legged stool too. It's a different stool, I think. But to fly an aircraft in the U.S., the aircraft has to be certified. So that's how the FAA knows it's safe. It's registered, so the FAA knows who owns it. And the pilot has a certificate, so the FAA is confident in that pilot's training and skills. So that's in statute. Those are in the law. So the FAA can't change those, right? They'd have to be changed by Congress itself. And of those three, certainly the aircraft certification is the hardest piece, right? Because that's a technical component. There's a lot of data involved. That's more difficult. So that's kind of the long. Well, to mix my metaphors, the long tent and the pole, the long leg of the stool, I guess. So part 107, how to fly drones. This is what Tombo was talking about. This was promulgated in 2016, the first set of comprehensive drone regulations. It applies to drones that are 55 pounds or less, and they're relatively limited. You'll see some of the limitations here, unless you apply for individual waiver from the FAA to fly above high altitude, above 400 feet, and beyond line of sight, those sorts of things. This has changed, right? So this is why at night is bolded in the third bullet. That's a new addition since the new rules that Tombo talked about came out. And part of the reason why the FAA, and this goes back to the see and avoid question, and why this rule is so limited, and basically relies on the operator to have responsibility for the safe operation of the drone as well as monitoring the airspace and the environment around the operation, is there just wasn't any data at this time. The FAA rules are should be and usually are driven by data, and so that's again why this rule is fairly narrow in scope, with the allowance for waiver, and that's why there's programs like Beyond, the US pilot program, the test sites that are up and running around the nation. So the FAA is trying to get data from all those flights, everything that's going on in those programs to help inform good policy and good rulemaking down the way. So of the three-legged stool that of mine, this one the aircraft has to be registered, the pilot has to be certificated. There's a remote pilot certificate that was created by this rule, but no airworthiness is required. No airworthiness certificate for the aircraft. It relies on a section in law that allows the FAA to allow operations on non-type certificated drones. So and I'll talk about that in a minute some more. So there is a way to get, so if you want to exceed the kind of base limitations, you have to get individual approval from the FAA in the form of a waiver, and that's particularly for airspace and the like. There's a short-term airspace approval through a program called LAMPS, and if you need a resource, the FAA Drone Zone website has all this information available. where you can get kind of rapid approval to operate in certain controlled airspace near airports. The kind of second way to operate drones under the law is this 44807 exemption. This has been around since 2012 in a previous form called 333, and these are all cleverly named after the sections in the FAA reauthorizations through the years that implemented them. Before Part 107, the FAA approved over 3,000 operators to fly drones for commercial purposes under the provisions of this section. Part 107 really kind of obviated the need for it, though, because if you're below 55 pounds, you operate under Part 107 generally. So, but if there's some limited circumstances, heavier drones, kind of different sophisticated operations, where an exemption might be the way to go under 44807. To get one of these things, you would apply to the FAA through a public process. You would tell the FAA what rules you want an exemption from, how you'll maintain safety to the same standard as the rules from which you need the exception, and why getting the exemption would be in the public interest. So the FAA would evaluate all of those. If they decide to grant the exemption, they would usually put in place a series of conditions, limitations that will talk about things like training, maintenance requirements, what your pilots have to, pilot requirements, things like that, to help ensure safety of your flights. Public aircraft is one, I think, because this is largely a university audience, is relevant. It's public aircraft are essentially government aircraft that are operated for limited purposes, and they have pretty stringent requirements on who can qualify, right? So you have to be a qualifying entity, which is a government agency, law enforcement, public safety entity. Public universities tend to be entities of the state government, and therefore can qualify. They have to be flown for a government purpose, governmental function. And I've highlighted the 2 or 3 that are particularly relevant to the university and research setting: aeronautical research, biological or geological resource management. Those are examples. And so things like, if you're looking at, tree canopies or erosion of stream beds and things like that, you could use drones under these provisions. Aeronautical research is research into aeronautics, into aerodynamics, sensor use, things like that. It doesn't mean anything that's researched by an airplane or using a drone. So that's what that is. You have to apply to the FAA. Again, for that, you write a letter to the Chief Counsel's office that says we're a state agency. Usually the Attorney General of the state might do that. You have to have a long-term lease on the aircraft, and kind of most importantly, even though it's the 4th bullet, it can't be for a commercial purpose. So you can't use public aircraft to make money, because the government does not want kind of this sort of operation competing with people who are complying with FAA rules. Because if you're a public aircraft, it's for this 3-legged stool, it's a build your own stool. You self-certify your pilots, you self-certify your aircraft, and you don't have to register it, right? So you get a lot of breaks that people who otherwise have to comply with the FAA rules don't get. So that's why they're concerned about that commercial use piece. A couple significant rules that just came out this year: remote identification. This basically answers the call of law enforcement. So part of the delay in policy development between 2016, when Part 107 came out, and now when these rules came out, is that law enforcement concern I was talking about earlier. How do we separate the wheat from the chaff? How do we know who's operating for bad, nefarious reasons and people who are just doing research and following the law? The answer is basically a license plate for drones. The FAA is going to establish through this rule different limitations on operations depending on the equipage of the drone. So if your drone is built with a built-in remote ID broadcaster that broadcasts information about the location of the drone, the control station, drone serial number, where you're headed, that sort of information, which will help other aircraft see and avoid you, and vice versa. And then also for law enforcement to be able to say, okay, who's flying this drone? If there's a complaint, right? Who's flying this drone? If it's built in, you really have no limitations other than what's in other rules, right? So if you're following Part 107, you still have to follow that. If you have an add-on broadcast module, for example, if you build your own drone and you add on the module, you're going to basically have to fly within line of sight. So you're going to be a lot more limited. If you don't have any of those, you're limited to basically model aircraft flying fields that the FAA is going to identify. Operationally, this takes effect in 2023. The second rule that Tombo also discussed is flight over people. And this is significant because this is now, and note the timing, this came out at the same time as the remote ID rule that now, it addresses law enforcement concerns. We can now open up to more operations, more kinds of operations under a rule. So this is going to basically lay out different categories for flights over people, depending on the amount of impact the drone would have when hitting a solid object. How much damage would it do? And kind of as a parenthetical, the rule's called operations over people and other waivers in parentheses, but they're significant, right? They allow flights at night and operations over moving vehicles under the rule rather than by individualized waiver. I know I'm kind of going through this quickly, but I want to finish up in time. And it'll be available for questions too. So just moving into kind of best practices for organizations. I think that first bullet says it all. Should we comply with state and local laws? Yes. I think there's open questions about whether they're valid under the federal government generally has regulatory authority over aviation. State and local governments generally have a more limited role, and arguably a lot of these laws the states and local governments are passing would be preempted by federal law. It's an open question that really hasn't been tested too much. So for a university or other organization that needs to comply with rules, I would say the smart path is to comply with your state and local laws until it's settled, unless you want to take them on, which I'm not sure many do. Sorry. Standards. You should have standards set to be, the purpose is really to be deliberate in how your organization is using drones, who can fly them, where they can fly them. And it helps ensure that your users are aware of the policies and any requirements that might apply, and also who's in charge, right? So there's a kind of a clear line of command. There's standards and processes. I want to highlight one piece on here. It's the last bullet about consider notifying others of your operations. People have generally reported that in as much as there's suspicion around people flying drones near them, it can be those concerns can be alleviated by providing the information. Here's what we're doing. We're doing research on this topic. We're flying here. We're looking at these power lines that happen to be in your neighborhood. Wear a vest that says, drone operator, and kind of have it look official. And then that sort of thing will put people at ease, like that you're not, snooping around or kind of doing things you shouldn't be doing. And then finally, we have some procedures highlighted here. The FAA, for example, and the NTSB have accident reporting requirements. So you'd want to talk about those in your policy, and again, maintenance, all these sorts of things that you'd want people to follow to make sure that your drone operations are tip top and in good shape. And again, this is the sort of thing that you can turn into if you need to go for an exemption or a waiver to the FAA. So we have all these practices in place. We're following it. We're a successful program. We're safe, right? At the end of the day, that's what the FAA concerns about is safety. And so that's the end of my presentation. And if people have questions after, I'm happy to take them, and also within the discussion. Thank you.
Great. Thank you so much. That's tons of info. Yeah, I've got questions, but I'll wait. Okay, thank you. So now we're going to be hearing from Lance Brady. Lance is with the USGS, the National Unmanned Aircraft Systems Project Office. I got to get that right. So Lance, go for it. Thank you.
All right. Can everybody hear me?
I can.
Excellent. So I definitely appreciate the opportunity to speak to UCGIS and to have the fellow folks on the call or on the panel today. I'm going to go into a little bit about what the U.S. Geological Survey does and with unmanned aircraft systems or uncrewed aircraft systems. We're specifically doing research. Here on the title slide, our website is uas.usgs.gov, and you can also follow us on Twitter. And that the Twitter site, we try to publish 2 to 3 stories a week, and it kind of is the latest and greatest of not only the research we're conducting, but the UAS operations that we're moving forward with. My name is Lance Brady. I've been essentially in aviation since about 1989, and specifically in UAS since about 2003. I have close to 20 years with the federal government, mostly within the Department of Interior with the U.S. Bureau of Land Management, and just recently have migrated to the Geological Survey where we conduct UAS research missions. And so who's the USGS and what do we do and why are we conducting these missions? And so U.S. Geological Survey is one of 9 sub-bureaus of the Department of Interior. And the Department of Interior has been, and USGS has been exploring the use of UAS since the early 2000s. And 1/5 of all the landmass in the United States is managed by the federal government, and 500 million acres is managed within the Department of Interior. And these agencies and lands are, like I mentioned, the U.S. Bureau of Land Management, National Park Service, Bureau of Ocean and Energy Management, U.S. Fish and Wildlife Service, and other smaller agencies. And so really for the USGS, we do have a mission specifically in our National Land Imaging Program of really this vertical integration of remote sensing data, all the way from satellite-based systems. USGS manages the Landsat system to what's listed here on the slide, specifically the high altitude, larger UAS systems, but also our manned aircraft fleet, both in contract, under contract, and agency-owned aircraft. And really where the UAS fits that niche is really the 1,200-foot above ground level and below missions where we really didn't have a suitable manned aircraft to conduct those missions. It was just too unsafe, and operations at that level just are a little bit more problematic for remote sensing platforms. And so the USGS, we're not a land management agency per se, but we are the science arm of the Department of Interior. So not only are we conducting USGS research, but we're also being funded by other agencies, both within the department and outside the department. We rely heavily on our relationships with NASA, the Corps of Engineers, Department of Defense, and others as well, and NOAA. And we conduct joint science missions and also science missions just within the department. And it's kind of interesting to note, we are the U.S. Geological Survey, and you would think a lot of our missions has to do around the geological resources that are out there, but in reality, most of our missions are not geologic in nature, except for specific land hazards like volcanoes, which I'll talk about here in a little bit, and some of our water resources could be thrown into there in terms of erosion. So a little bit about the creation of the UAS program within the department. So our technology investigations really started, like I mentioned, in early 2000s. It's listed here 2004, but other agencies were exploring well before that. The office that I'm in, the UAS National Project Office, was created in 2008. We soon acquired some Department of Defense systems in 2009 and started operator training in late 2009 and 2010. And at this post-training, we conducted most of our missions within restricted airspace. So we had authority from DoD in the managing managing folks that work for the Department of Defense to get access into the restricted airspace. So we conducted several missions, and really the first mission that was conducted in truly national airspace, Class G, was in 2011. And interesting enough, that first mission was a nighttime operation that was beyond visual line of sight with a military aircraft that we were flying. In the upper right-hand corner there is the RQ-11 Raven. That was the first aircraft in the national airspace by the Department of Interior and U.S. Geological Survey. And we've kind of have migrated our ways through from using DoD offloaded equipment to commercially based systems. As you kind of see in the sub-bullet at the very bottom, in 2019, there was a secretarial order under the Department of Interior that temporarily ceased our UAS operations. We're still under that temporary ceasing. In 2019, when that happened, we had 11,000 flight missions that occurred in 2019. And after that, in 2020, we had approximately 4,000 flight missions. So we saw a substantial reduction in the uses based on that. And we can go into the policy implications and why that occurred here in a second. But really, the operations were centered on only allowing for emergency response missions and characterization of land hazards, which would include volcanoes and flooding, avalanches, and things like that. Our research is in terms of readiness, where we are conducting missions that kind of fall outside those characterization of land hazards, but it's really to be mission ready to respond to a national emergency. The ceasing of UAS operations in the Department of the Interior kind of set the stage for what we had seen, not only from presidential executive order under the prior administration to specific policy and legislative progress that, or I guess progress is a bad word, but there are concerns by so-called covered entities or covered foreign entities, where some of the systems that we're using are either mass-produced or produced in countries that may or may not be friendly to the United States. And so we were the first agency to kind of be cut off. Number one, DoD has a pretty secure systems that they're utilizing. Department of Interior is probably, well, it is second to the DoD in terms of the just sheer number of aircraft we fly and the number of operators. With the USGS, we have 137 UAS remote pilots and approximately 200 individual aircraft. In the department, that kind of ramps up to about 850 aircraft and 450 remote pilots. So we have a substantial program, and there was concern that information was getting passed to foreign entities that we were conducting, even though 99.5% of our missions are public record and data is released to the public via either FOIA or distributed online through our AROS data center. So a few of the aircraft that we're currently flying, we're on our third, maybe fourth generation of aircraft. So the Matrice M600 is our kind of our workhorse heavy lift aircraft. We have one fixed wing in the Firefly 6 Pro. It's a vertical takeoff and landing fixed wing mapping platform. We have a Pulse Vapor 55. It's also a heavy lift aircraft as well, but a little bit more complex, a lot more complex to use than the Matrice M600. 3DR Solo, the DJI Mavic Pro, and the Paradanafi. And we are, due to the grounding and other issues with Department of Defense and intelligence communities, we are moving to look at procuring of what's called the Defense Innovation Unit Blue UAS, not only the first generation, but also the second generation of platforms. This is just a real quick example of the thousands of missions that we've conducted since 2011. I'll go a little bit into the Kilauea volcano eruption response, the Devil's Tower National Monument in Wyoming for the National Park Service. We created a 3D model using a UAS of Devil's Tower. We are a group of photogrammetrists and remote sensing professionals, so that is kind of the niche that we are in. And so this is just an example of some data products and a mission out of Colorado specifically to photogrammetry. In the lower left is Palmyra Atoll out in the Pacific, where we were outside of the FAA's responsibility. We were operating in international airspace, and so we were operating under a different set of rules as public aircraft out of Palmyra Atoll. And that's a multispectral project. And then we also have been flying LiDAR for a number of years. That's just an example of a LiDAR point cloud, colorized LiDAR point cloud of Fort Laramie, National Historic Site in Wyoming for the National Park Service. And then also an algal bloom research mission in Kansas using multispectral data. This is just a few slides from a master slide deck of 72 slide decks that are slides that I do have on different missions that we've conducted. Needless to say, we are exploring and actually flying numerous sensors to include not only photogrammetric cameras, metric cameras. We are flying numerous LiDAR missions. Our crew is headed up to the mountains of Colorado today to conduct 2 weeks of post-fire monitoring from a wildfire last year using basically LiDAR and our 10-band multispectral imager. We've also conducted operations using hyperspectral sensors and custom sensors like a ground penetrating radar unit, a Doppler radar unit for conducting stream measurement in velocity flows, and then we've also conducted missions using what's called a hydro sleeve. So this is a water sampling device that hangs by the bottom of the drone, and we can dip it into different water sources and test the water chemistry once the aircraft is back. Within the Department of Interior, we also have what's called a Psd machine. So it's a chemical sphere device that drops, it looks like kind of ping pong balls, that when injected with a solution creates an incendiary device that we actually start what's either on prescribed fire or backing fire around a wildfire scenario. So each of those operations under our regulations within the department, we have to be what's called carded or approved and trained to conduct those missions. And so, before Part 107, we were operating under certificate of authorizations from the FAA. Our training program was approved by the Federal Aviation Administration in 2012. And so not only are our pilots required to have Part 107 certification, but they're also required to have Department of Interior specific aviation training, which includes operations, like I mentioned, flying beyond visual line of sight, flying payloads, dropping payloads. So there's different operations and certifications that go along with each of those mission sets. So a little bit kind of our long-term monitoring that we conducted at Kilauea. There was a volcanic eruption in 2008, and we cycled hundreds of pilots through, I wouldn't say hundreds, not quite 100 pilots through 24-hour operations for 4 or 5 months during the active eruption. And so we were conducting air quality monitoring or air monitoring. We were conducting photogrammetric missions as the landscape was rapidly changing. And as we actually had an aircraft airborne when there was a 5.4 magnitude earthquake that happened, which caused some major deformation of the volcanic crater. And so we landed the aircraft, were able to get airborne, and we were able to conduct another photogrammetric mission just shortly after the eruption. So we had a post-event and a pre-event and a post-event flight that occurred over the eruption. And we conducted a lot of beyond visual line of sight missions at the eruption. We were operating under a temporary flight restriction, which allowed us to do that safely. And we conducted a lot of missions in a lot of flight hours of time on the eruption. These are just a couple of the images from the UAS that were flown. And interestingly enough, our Doppler radar unit that we use conduct velocity measurements for water was actually used to calculate velocity of the lava flows coming off Kilauea. This is just an example of one of the 3D point clouds, and for the actual crater itself, you can see some of the land deformation, some of the cracks, some of those areas sloughed off during that big volcanic big earthquake event that we were able to capture in near real time. And as I mentioned, water sampling, the hydrosleeve, this is just the scientists doing the water chemistry of sampling at the bottom of the crater on some water that happened to be had accumulated. And so that's really about it for my presentation. This is the great team I get a chance to work with, along with the other 130 some pilots that are out there with the U.S. Geological Survey. And with that, I'll turn it back over.
Great, thank you so much. Wow, that's a ton of stuff you're doing. That's, yeah, really fascinating. Okay, great. So thank you to all three of our speakers. We're going to be moving now into our discussion sort of section, and I'm hoping that we can get some questions from the audience. I see Adam Matthews, one of our discussants, has just put in the chat. Please feel free to ask any questions you may have for our speakers. You can do it there, or you can direct message Stephanie or Adam. And the direct message is the little airplane right at the top of your screen, I believe. Yes, it is. So you can do that. And they'll do their best to work them into their long list of questions that I'm looking at right now. So I'm going to turn over to them, and yeah, take it away, Adam, Stephanie. Thank you. I'll just hang out here, and we'll try to field any chat questions. Paddington and I will do that, and see how we go. All right. So Stephanie, have we got Stephanie in here yet? Yes. Oh, well, how interesting is this? Stephanie, I'm going to let you in. And Adam, I'll let you in. Oh, I've never done that before. There we go. You're online.
Thanks for letting me in.
Sorry, I was like, where are they?
I don't know if you also want to bring the panelists back as well.
Yes, I should bring the panelists. Oh, hold on. And Dean is back. Right, Dean? I just let you. Oh, and Tombo. Right, so we have our three panelists, and then we have Stephanie Rogers, and where did Adam just go?
He's here.
Oh, there's Adam, sorry. And Adam. All right, so I'm going to turn off my video just to not confuse things. Guys, go for it.
Okay, great. Well, thank you, everyone. That was very informative. We have some sections of different types of questions. So I'm going to start off with some of the more operational questions. And maybe this first one could be for Dean or Tombo or Lance. I mean, you can all feel free to jump in. But basically, how adequate is the FAA Part 107 remote pilot rule in creating safer skies, first of all? And what will the future look like for the beyond visual line of sight? Maybe Dean, you want to jump in on that safer skies?
Sure. I think the way it creates safe. But I think what's interesting about 107 is that it doesn't have kind of much in the way of the traditional FAA thinking on how we know that an airplane and its operations are safe, right? Because there wasn't the data at the time to know what it takes to make a drone safe. And so that's why it's really limited to within line of sight, low altitudes, previously day, now night, provided you light the drone so it can be seen from 3 miles away, and the pilot gets additional testing. So we're building in some of those safeguards. On the waiver piece, a lot of the waivers the FAA has granted to date are for night operations, right? And that's how they were able to incorporate the rule for altitude, altitude adjustments, so fly a little bit higher. But they really scrutinize it, and there's been a handful of beyond visual line of sight waivers granted. I think a couple of operations over people, but they look very closely at the safety case. And I'm sure that Tombo has a lot of experience with this because they're going through right now with an exemption process, and they have the beyond visual line of sight operations. But what the FAA wants to see is a concept of operations. And actually they've been fairly helpful in publishing a list of questions that they would want to see answered in a waiver petition that really lays out, how are we going to figure out detect and avoid, right? How are we going to make sure the drone's safe? It lays out questions to think about and then to answer proactively. So they're very controlled and tight right now with that, and that's kind of particularly once aircraft become more commonly certificated. I think we'll see beyond line of sight open up more, but I think until then it's going to remain pretty tight.
And following up on that, maybe for Tombo, what drone capabilities are needed to support effective beyond visual line of sight, and how can we integrate this in academia? Sure,
yeah, great question. Thanks, Stephanie.
Thank you.
I'll start by just echoing what Dean said. Part 107 is largely just focused on reducing exposure to people and also exposure to other aircraft. And the rule's written very much with that in mind from a safety mindset. And when we look to beyond visual line of sight, what we're largely trying to answer there is as we have rules that are coming forth, the first one being the operations over people that really is applicable to beyond visual line of sight. And in the future, we expect to have a rule that specifies what detect and avoid capabilities are necessary, what thresholds are necessary to meet the requirements. There are some standards out there, but I think we've got a ways to go, both from as a research entity collectively and as an industry. We've got to really do a good job of helping support the FAA in learning the capabilities of these sensors and where their efficiencies are lacking, so that we can really focus upon answering the mail on how to safely conduct flights beyond visual line of sight that allow us to see and avoid other aircraft and that allow us to operate over people. And Dean mentioned the certification process, and that the purpose behind that right now on the streamlined durability and reliability process for drones is to show that they're reliable enough that we don't have to reduce the exposure to flights over people.
Great, thank you very much. Okay, so Dean was touching on some of the confusion often between different legislative bodies and their rules, for example, on a university campus, within the state, within the local community. So especially for people who don't fly their drone that often, let's say some academics fly in the summer, maybe, one time a year or 2 times per year, it's hard to keep up. So how can we make sure as academics that we're staying safe, and which rules do we ultimately follow? And I don't know who wants to tackle that one.
Well, I would point people to the FAA website. One of my complaints as a lawyer is that some of the rules are too easy to follow, and they don't need to hire me necessarily all the time. But the FAA, they have a lot of information there. There's a great app called Before You Fly that the FAA developed and has been since taken over, kind of a public-private partnership that lays out airspace, any restrictions that might be around there, where you want to fly. So I would download that and look at it. But those are good sources. And like I said, I think if the FAA doesn't have a large inspector force to go around to parks and places like that and tell people not to fly, right? And that's always been the enforcement issue they've had. Enough that there was an article from a wedding magazine kind of geared towards wedding photographers and said, don't worry about the FAA. What you need to be concerned about is the local law enforcement. But you need to if you pay attention to that, the FAA site, and kind of just be aware, if you can, of what's happening in your location where you're going to fly. But national parks, as far as I know, they're still off limits. That'd be my advice. I don't know if actually people who are actually out there doing this have any practical advice.
Hey, Dean, this is Lance from the USGS. So I would say that in terms of research-specific things that are happening in the national park, there is a permit system that you can get permitted to fly on the national park systems, and so that's how we generally operate, is under research permits. And I know academia can also get access to the same permitting system.
Good to know. Okay, so just kind of hopping back to the remote ID, as this is a new thing that academics are a little bit afraid of because we have already purchased equipment, and we're wondering, what it will look like to retrofit and how expensive it will be. But how do you expect remote ID to impact users, drone users in academia and beyond, and what kind of retrofitting, what does that look like, and how much will it cost us?
Dean, do you want to jump on that, or you want me to answer that?
And I'll fill in if
Sure, that'd be great. So Stephanie, when the rule was proposed and came out, there were certainly some great concerns about remote ID stifling research students, if you imagine, that are learning about aeronautical research and designing their own drones that, are made of cardboard, for example, or even more sophisticated drones. That requirement, how it would require them to take, steps that were really burdensome when they were simply going to be flying in an institution's place for learning how to fly, and not out operating, for example, in neighborhoods or in a place where, there would be concerns about privacy, who's operating this drone, is it nefarious? The rule does allow for certain entities to apply for a designation, and it's a geographical location designation. I don't want to say an exemption, because that's not what it is, but it's for the rule, it's part of the rule, and it allows an entity such as a research institution to apply to do just the types of flights that I'm talking about, that are, very much people design, build, fly, for example. And it's not restricted just to those type entities, but it does allow for that. And Dean, I don't know if you want to drill into that anymore, but that's something that's been certainly at Virginia Tech's the forefront of our mind with the rule, and we were paying close attention to it, and we're glad to see it included in the final.
Yeah, I think interestingly with this and the remote ID, over people, when the FAA was looking at costs, they factored in that the drone fleet kind of nationwide turns over every few years. I think it was every 3 years or so. They kind of they figured on 3 years until obsolescence, and so they're able to justify some of the costs using that assumption, which I thought was interesting. But the manufacturers will have to start producing remote ID compliant drones by September 2022, and then the operational provisions for remote ID take effect in 2023. So that's kind of the time frame we're looking at there. But yeah, there is a provision for adding on a module as well, if you're building your own.
Great. So there is a bit of time. I'm happy to see that, but it's still a bit daunting when you have, $20,000 pieces of equipment sitting in your lab waiting to be used. Okay, so just one more on the operations side, and then we're going to head over to Adam and the education questions. So none of you, I don't think, touched on this, but drone insurance is an easy to overlook necessity within academia when purchasing drones and related equipment. Can you tell us about your experiences with insurance for your own personal equipment, or in the USGS, for example, Lance? What do you all do to insure your drones?
So USGS, it's a really easy answer. The government self-insured everything of whether it's a ATV or whether it's a vehicle or our facilities, we are considered self-insured. So insurance for UAS operations is something we don't have to consider.
Tombo or Dean, do you have any inputs on that? I guess it's different for every academic institution. I know with some of my colleagues, we've had these conversations. A lot of people don't even know it's a thing. Some universities have a better sort of streamlined, okay, you do this, then you do this, and you're registered through, or you're insured through the university or your department. But there's no real, exact recipe for how this is done. I don't know if anyone else has a comment on that.
We'll say here at Virginia Tech that we're a Commonwealth entity, and so our insurance requirements fall under that. We do have insurance for the drones that we operate, and when we perform work for with partners, for example, and they bring their drones for that research, there is an insurance requirement. And interestingly, it's obvious that it's very early in the industry and where those thresholds lie, because we have to ask certain questions that our risk management department then will determine the level of insurance required. The one other thing I'll say, I don't have a lot of experience with the commercial drone insurance, but I know very much that there are insurance agencies that are starting to insure drones. We do train some operators here, and that are large news agencies, and they do have their drones insured through traditional commercial insurance providers.
Okay, great. Thank you. And Adam, I'll let you take it away.
Yeah, actually I have a question that I'll ask Tombo that came up in the chat from Stephen, which is, are there universities that have good operation plans and policy documents to share as we move into this domain? So what does Virginia Tech have? Or do you know any other universities that have some good stuff that folks could look up?
Yeah, I think that's a great question. So I'll just share that at Virginia Tech, our staff here at MAP, the Mid-Atlantic Aviation Partnership, we come with a very traditional aviation background. I have a number of people here that have certifications to fly, normal traditional airplanes. And because of that, we have a pretty robust program that we're proud of in terms of, our operational risk management. It's very similar to the way that other government agencies approach aviation research. We have our own operating procedures. I think Dean mentioned having standard operating procedures is a very important pathway forward. And we have our own training programs, and we actually do train other entities. Sometimes we will share some of that stuff, especially some of our risk management documentation. And as an example, some of our, we're not afraid to share our operations manual. I will tell you that the FAA has a program called the Assure program, which we've also been a part of on some projects. And those Assure programs are working to help define for the industry what good policies look like from internal organizations. And if somebody wants to link up with me afterwards, I certainly can point you in a direction to some examples of standard operating procedures and best practices that will keep you and set your organization in the right direction. And Dean, I know you commented on that some in your slides. I don't know if you had anything on that as well.
To that, that's a fulsome answer.
It's interesting because when I talk to colleagues on other campuses, it's just kind of all over the place what you hear, right? Oh, we have this committee that does this, and they're made up of this. It's just pretty inconsistent, which is to be expected, right? It's a pretty complicated matter, and there's a lot of people involved. Okay, I'm going to ask a few questions, or a question or two about education and curriculum. So in academia, of course, we're interested in, educating our students, and where UAS and geospatial data collection and creation, where that fits in. I guess this will be for Tombo and Lance, and that is, what are kind of like what would you say the skills that you would see as most important for, say, adding members to your team for, creating map data, doing map analysis, those types of things?
Yeah, you want USGS to hit that one first?
Yes, please.
Yeah, so it's kind of interesting. Been working with a couple university programs in establishing what their UAS curriculum is going to look like. And you kind of have two different branches. One coming out of traditional aviation education, and then others that are in maybe a natural resource field that basically want to use UAS for the research. And I would say that out of the 850 pilots, remote pilots that the department has, it would be probably less than 1% that come from a professional aviation background. The majority of our UAS operators are coming from some natural resource type field, and they're just using UAS to get their sensor in the air. And so the skill sets that are needed are a little bit different for the department, in that we train folks to the same standards as professional aviators. Our programs, policies come out of our manned aircraft programs, but just like the U.S. Fish and Wildlife Service manned aircraft pilots, that's what they do, but they have technical backgrounds in either as a wildlife biologist or as a law enforcement officer, and they're just using the aircraft as their tool. So really it has to do with whatever natural resource you're conducting missions for. Number one, we want folks that understand, that they're having to follow policy, that we don't want rogue operators out there that are going outside of our policy that we set, both on purchasing aircraft, on flight operations, and number two, that they're cognizant of the risks and the dangers of flying UAS in the national airspace. They are small. We've had very few incidents, but if something were to happen, it will make national headlines, and we don't want that to happen. So we take it serious on vetting who comes into the programs across the Department of Interior, and but it really, like I said, it doesn't. We're hiring professional aviators, but they're not coming from an education or an academia or aviation background.
Tombo, did you have anything you wanted to add there?
I'll just say that I agree with Lance in terms of, the best operator that you can hire is somebody who knows the policy and is willing to be a professional and make sure they're following the policies and manage the risks, because many of the drones that are employed today to do mapping missions really are more of an automated type, and they're flying a software program. We don't expect the pilot to fly, at least in our case, we don't expect the pilot to go fly a parallel search pattern or some type particular search pattern to be able to provide overlapping images that are necessary at particular 70% overlap or something of that nature to be able to get the images you need. The commercial off-the-shelf products typically come with that. I will say that if you're really pushing the boundary research-wise and trying to figure out how to improve these things, when we hire people, because we're kind of at the forefront of looking at drone technology, computer science folks are pretty important. But I'll agree with Lance there that the best operators that you can bring on board are people that are willing to follow the rules. That's probably the most important piece.
Okay, great. I think I'm going to take the next question. We're flying through our time here, so I'm going to switch it up, and I'm going to open it to all the panelists. But this one's going to be about inclusivity. So Adam and I and a couple other colleagues have a paper in review at the moment where we did a small we did a small survey of about 80 respondents, and we found that in academia, most drone users are white males, with the younger cohort actually representing females. So from the 18 to 24 age group, we saw 75% female drone users. So there is an uptick at the younger age categories, but I'm wondering if this is reflected in your job applicants that you see or people that you interact with in your field, and how can we get drones and drone technology to be more inclusive?
So I think you hit something on the head there, and I wouldn't just limit it to drones, but also to STEM programs in general. We try to do a lot of outreach at not only the USGS, but in the department to our STEM universities that are out there, and even starting at grade school and in high school level to engage into the STEM sciences. I think at least for NUPO, we have 2 females on the staff. One of our head researchers on radiometric calibration. She's fairly new to our group. It's very difficult to speak in these large generalities for the 850 pilots that are out there in the department, but you probably hit it right on the head in terms of our current makeup. And a lot of it doesn't necessarily have to do with drone specific diversity, but also in our kind of an overall STEM diversity issue that I think all federal agencies are struggling at the moment.
See similar trends in GIS as well. Adam has a recent paper out which kind of highlights the same trends that we're seeing. So maybe more broadly, what can we do as a group of users to recruit people from minorities or people of color or more women, or just to start the conversation about being more cognizant of who we hire, who we're training, who has access to drones. Anyway, I just wanted to bring up that inclusivity aspect because I do think it's an important one.
Yeah, Stephanie. Oh, sorry.
Go ahead, Tom.
Go ahead, Dean.
Oh, go ahead, Tom.
Okay. So at Virginia Tech, I'm sure like many other institutions here, inclusivity is a very big focus of ours. And there have been a number of programs that we have sponsored over the years. We have a drone park here, which is a netted cage facility where we can teach operation of drones in a very, safe and for folks that are very new to it. We have had some programs here that are STEM oriented at high school students where we, have had as many as 150 students a week at a time coming to learn in our lab and fly our drones. It's been very rewarding for us to see that. We feel like those type programs that introduced, folks that may not have the ability to purchase what right now sometimes are expensive drones, are very important in pushing or moving that needle, if you will. The one good thing I'll say about the drone industry is, the traditional aviation industry was very, very hard for someone who did not have a lot of money to get into because it's very expensive to get a pilot's license, right? And so while drones are somewhat expensive, they're becoming less and less expensive, and it's an industry that could really invite folks that are, let's just say, a much more diversified group than traditional aviation. All of our hiring efforts here have objectives that we try to meet to diversify. Our program, personally, I wish it was more diversified. I will say that we have, I think it's 20% women. We do have real proud of one of our most recent graduate students who did a phenomenal job of defending her thesis on detect and avoid technologies, just like I was talking about. She is going to do great things and just got hired by NASA from us after working for us as both a wage employee and then a graduate student. So proud to see her, and that's just an example of one of the females that we have here. And so I think it's very important. I don't know that we have all the answers, but I appreciate you asking that question.
Yeah, I was going to add that aviation is traditionally a male-dominated industry by far, and the FAA has two task forces, one on education, focus on education, and another on women in aviation broadly. So they're looking at the issues, at least on a gender standpoint. And the fact is that this is, like Thomas said, drones are relatively inexpensive. They're portable. They're small. So there's a real opportunity to get hands-on in a lot of communities and get people hopefully interested in this technology and science and aviation generally.
So much. That's not an easy question to tackle, but I think it's important to bring it up. And there's one question that just came up in the chat from Nicholas. To the men on the call, what are you doing to make your field more accessible to women and other minorities? Maybe you've touched on a couple of those already, but I guess more concretely, what can you say to address Nicholas's question?
I gave the example of some of the minority programs where we have students come to our drone park. One other thing that's pretty exciting is our library. Allows folks to check out drones at the drone park and go use them free of charge. And so that was an initiative that Virginia Tech put together where we purchased a dozen drones that were relatively, small and maybe able to replicate a drone that would be less expensive to purchase off the shelf. But if folks wanted, all you have to have is a Virginia Tech library card, and you could go to our lab, sit through a small class on how to operate the drone, and then go operate it in the drone park. And so it's just a way to introduce to folks that may not be able to afford it.
That's pretty cool. Thanks. Jane, how are we doing? I think we are just about out of time. So
Yeah, we're over.
We have until 6:15, so we should not go over because we don't want to bump into the next session. This has been great, and I love that we've ended on this whole diversity issue. I don't know if any of you were listening earlier when we were talking about the UCGIS at 25 conversation, and one of the big points in there is that one of the things that UCGIS can really help to do is really try to diversify. That's sort of one of the things that we probably should be focusing on. So yeah, maybe we can all come up with something, come up with some projects. Maybe the next symposium we can be, linking up with industry wherever we happen to be having our symposium, if it's somewhere in person, and and be working with industry partners and trying to get communities of color and young kids involved. I think it's really great. All right. So does anybody have any final comments they want to say? I think we could all probably go on for a really long time. But any final comments from anybody? Paddington?
Thanks, Jane. And I guess on behalf of myself and Jane, I want to thank all our panelists and discussants for such an informative and engaging session. There are obviously many ideas that came up that I think are going to come in handy for many academic departments that are on the verge of developing or growing their drone programs. I'm sure UCGIS is going to play a role in shaping the trajectory of these programs, influence policy making, and development of best practices. And hopefully we have another session at next year's symposium to update folks of any developments. One of the things that Jeremy Menis and Jane and I have talked about in the past is the idea of putting together a white paper on UAS, and that's something that we will try to work on in the next few months, and we'll keep everyone posted on our progress. So thank you, everyone, and enjoy the rest of your day. Thanks.
Great. Thank you, everyone. And thank you for filling in the polls. I don't know if anybody actually looked at the results, but the results are out there. So it's actually quite interesting, that actually there's not a ton of us who are actually using drones in our research on a really regular basis. And I suspect that a lot of these barriers that we've been talking about is something that has been stopping a lot of people. So anyway, all right, well, great. Well, thank you so much. Go enjoy your Monday evening. After this, I'll just say to everybody that at 6:30, there's a session on co-teaching with librarians. So I think you need to leave this session and then hop into that session at 6:30. All right, great. Well, I hope to see many of you, all of you, I don't know, at other sessions for the next few days. Thank you very much, and take care, everybody. Bye.
Bye. Bye.
Thanks.
It was fun.
Bye. All right. Okay, I think we're done.
We're done. Yep, that was really good. Yep.
Okay. All right. Bye, everybody.
Bye.